All right, guys, that was the one and only example problem from this unit. The next 3 pages are supposed to be your practice problems. So you're going to find the equation of best fit. You will follow the steps I just did on the practice problem we just did together. You're going to take your table, put it in Desmos. I have all 3 regressions here. There's your scatter plot. Do you see the green dots? There's the linear one. I'm guessing that's not the best. If you look at your R value, R squared value, R squared is 0.717. Not so good. Here's your quadratic. What do you think? I, I once again, it's going back up. It's increasing and going back up. The only dots we have, it starts here at 0 and it's going up. It's not just logically not the best model. I mean, its R value is 0.96, closer to 1. So given these two, definitely your quadratic would be a better fit, but still, there's nothing to indicate that this function is going to be rising again. It's not a word problem this time, like the K one was a word problem. So we go, oh, it was radioactive decay. That's going to decrease. It's never going back up. With this data set, it's really hard for me to believe that it's going to go back up. Go down at, it has a vertex down here, a minimum value. And then what's going to tell me that it's going to go back up? So that's going to be like if it was over here on the negative side, that those values are going to have higher y values. And then lastly, well, once again, you can see that our exponential regression, this is a unit on exponents, so I'm exponential function. So there you go. It's going through all the points. Oh, it misses that one slightly. Our A value is 1.5. Our B value is 2.7. So I want to talk about something real quick. So let me write the equation out. Y equals 1.5, because I don't want you to forget these things. 2.7 to the x. How do I know from the equation that it's not linear? The x is in the exponent. Remember, this is our b value. Our b value is greater than 1. That's what tells us it is a growth function. It is growing. Our a value is our y-intercept. Sure enough, that point right there, well, not the point we graphed, but the one where our function is crossing is 1.5. The one on the table was, what was the one on the table? It was 2. So remember, regressions are estimations. Our value was 1, so it's pretty spot on this time. And is there anything else we need to talk about with our domain? Our domain with exponentials is all real numbers unless it's a word problem. If it's a word problem, you might eliminate your negative values. Like our exponential decay one from the example problems, time, will it be negative? Is there going to be a time where it was negative? No. This is the amount of material you had. It starts decaying over time. Our range is going to be y is greater than 0. It is always going to be y is greater than 0 unless you add on a plus or a minus to shift this up and or down. All right. I am going to leave 2 and 3 for y'all to do on your own. You're just going to do the exact same steps I just did. If you preload this into Desmos, you'll just have to go and switch your table values, and these will switch automatically. Make sure it has x1, y1 there, not x2, y2. Make sure in your regressions you have y1, and on your x you have a little 1. So here's the one for your exponential. Good job. Oh, I didn't tell you what to write here. Find the equation of the line of best fit. You are going to write the equation. The equation is what I just wrote right here. This is your answer. Okay? 1.5, 2.7 to the x power. So you'll come over here and type this in the little box that's going to be there. Y equals 1.5. I really didn't need those parentheses. 2.7 to the x. All right. Now, good job.